This is my video for CIS220, week with the Sunday date of November 17th. This week we are given a file containing prime numbers from 0 to 5,000, excluding 2, 3, 5, and 7, so that all of the prime numbers are at least 2 digits long, if not 3 or 4. We are then going to use that as our key to actually figure out which wheel that we would actually use as within our wheel dictionary. So this is the number list we were given. It goes from 11 all the way to 4,999. All of the different prime numbers between those. And then this is the actual program that I used to create a Python file containing just prime numbers that we'll then use later for actually figuring out which wheel we'll use. So we start with just getting a file, which we use to pull in the prime number list. We then randomize it so that it's not ordered as it is now, and it's completely random. Then we use that to create a new file that we call prime numbers. And this will create a new dictionary for all of the prime numbers, giving a key value pair where the key starts at 1 and then increments upward up to, I think it's 665 for all of the prime numbers between 0 and 5,000, minus 2, 3, 5, and 7. And then we'll use that later on. So prime numbers is that file that's generated by this. And as you see, doesn't do a great job of being very readable, but at least just to show you, the key increments by 1, and then we have a random associated prime number that's from 11 to 4,999. And this goes all the way to 665 prime numbers, and from there we'll actually use it in our prime wheel picker. Wheel dictionary is from our different setup that is very similar to this, where we have a bunch of randomized letter sets that came from our original letter set, and then we just have a W1 through W100 for the 100 wheels that we created. They're all randomized. The last two programs are prime wheel picker, which the prime wheel picker doesn't do too much. This is what we created working with John. So I don't know too much about that program, so we'll go to that later. But wheel selector was the one I created. And it doesn't take too much. We import the prime wheels, or the prime numbers, and then we import the wheel dictionary. So we have two dictionaries, and then all we do is just create a little function called wheel selector. You select what you want your key to use. So I picked 5, and then we'll go through and we use that value. So we go and select the 5th prime number from our dictionary. Then whatever that number is, well, we can find out actually. 5 would be 2,729. We divide it and get the remainder by dividing by the number of wheels, which is 5 in this case, which is just what we decided to limit it to. We could have done up to 100, as that's the number of wheels we have in the actual dictionary. And then we create a variable that's just adding a W with the number, because that's how I named the wheels in the dictionary. Then we create a new variable that gets that wheel, and then we return it. So if we run this program and say we use 3, we've gotten a wheel that is multiple times randomized, so we have no easy connection to be able to find out where this came from. But as long as you type in 3 every time and you use these two prime number dictionaries and wheel dictionaries, you'll always end up with the same one, and that way you'll always be able to encrypt and decrypt messages as long as you have the key. Otherwise you'll have a tough time being able to actually do that. John's program is a little bit different from mine, but basically does the same thing, except the way he gets to the prime or the wheel is a little bit different, but functions the exact same. And then he takes in 3 wheels instead of just 1. But for the most part, it's basically just the exact same thing. So you just enter in 3 numbers, and then it outputs what you want. So the key is basically the same. It's just in our main program we take in a key of 3 digits, and that way his program takes in 3, where mine was just 1. But if you ran my program 3 times, it'd come out to the same thing. So there's not too much of a difference there. And this week wasn't too hard to figure out how to do. Being given the prime number list was convenient, but would not have been too hard to figure out, as we already have programs for finding prime numbers. But I think this was a good lesson in, making a simple program that can do a job that was very useful for our project, to add a little bit of extra difficulty, because before we didn't have keys. So that was pretty useful to add. That's the end of this video.